Hello and welcome to the lecture. So, in this lecture, we are going to start a new topic which explains all the limitations which were posed by Valence Bond Theory. And this new topic, it is called as Molecular Orbital Theory, or it is simply represented as MOT, Molecular Orbital Theory. Now, first of all, we will look into important points that are important regarding molecular orbital theory. So first of all, as we know that in atoms there are atomic orbitals. And electrons, they mainly reside in atomic orbitals. So in case of atoms, we have atomic orbitals where electrons are found. But when we talk of molecules, there are present molecular orbitals, or in other words, we can say that electrons, they are found in molecular orbitals in case of molecules. And the another important thing is that molecular orbitals, they are formed by combinations of atomic orbitals, and in this process they lose their identity. So whenever atomic orbitals they combine and when resulting in the formation of molecular orbitals. Now in doing so they lose their identity. So we have atomic orbitals, they combine to form molecular orbitals. Now in combinations, atomic orbitals, they lose their identity. So when molecular orbitals are formed, we can't say which atomic orbitals they are being formed, that is, they lose their identity. Another important point is that only those atomic orbitals that have same energy and same orientation, they can combine to form molecular orbitals. Now there are two conditions, one is energy condition and another is orientations. Now energy wise, the atomic orbitals, they should have same energy, only then they combine to form molecular orbitals. Suppose we have 1s and 1s, here 1s and 1s, so they have similar energy. So when it means that they have similar energy, so they can combine to form molecular orbitals. But instead, if we have here 1s orbital and here, if we have here 1s orbital and another is suppose here, that is suppose 3d orbital. So since they don't have similar energy, so it means that they will not combine to form molecular orbitals. So only those atomic orbitals having similar energy, they can combine to form molecular orbitals. Similarly, we have another factor, that is orientation. It means that they must have similar orientation. Suppose we have s orbital and we have pz orbital. Suppose if I take pz as internuclear axis, so here both s and pz, they have proper orientation, so they will combine to form molecular orbital. Instead, if they combine like this, if suppose this is px and here comes s orbital, so since they don't have proper orientation, proper orientations, so they will not combine to form molecular orbital. So there are two necessary conditions for atomic orbitals to combine to form molecular orbital. One is energy factor and another is orientation. Now there are certain other facts, other important points. Now as we know that atomic orbitals, they are filled according to increasing energy, and we know that atomic orbitals, they are filled according to n plus l rule. So atomic orbital having low n plus l value, they will be first they will be first filled. Similarly, molecular orbitals, they are also filled according to increasing order of their energy, order of energy. Another important point is that atomic orbitals, they are monocentric in nature, whereas molecular orbitals, they are polycentric in nature. What does that mean? Suppose we have hydrogen atom. It possesses one nucleus. Now it is having outermost shell, K shell, and in this K shell we have 1s1 electron. Now this one electron, it is in effect of single nucleus, that is, it is monocentric. Whereas if I talk of H2 molecule, so in case of H molecule, we have two nucleus, and the electrons are these electrons, they are between the two nucleus. That is, when molecular orbitals are formed, single molecular orbital is formed, that is, they are controlled by two nucleus. It means that it is polycentric in nature. So atomic orbitals, they are monocentric, that is, they are controlled by single nucleus, whereas molecular orbitals, they are polycentric in nature. And another important point is that atomic orbitals, as we know that, they are represented by S, P, D and F. Like we have 1s, we have 2p, we have 3d, we have 5f. So it means that atomic orbitals, they are represented by simple S, P, D and F, while as molecular orbitals, they are represented by sigma star. Similarly, we have pi, their pi star. Similarly, we have delta or delta star. So this is the representation of atomic orbitals, and this is the representation of molecular orbitals. Now, whenever atomic orbitals, they combine to form molecular orbitals, they combine by linear combination of atomic orbitals. Now, as we know that whenever, since particle electrons, they have wave nature, and one of the property of waves is interference. Now, as we know that waves, they interfere either by constructively